Alright, so this is a suggestion via Discord. The name of the video is why monster waves can't sink the largest cruise ships during heavy storms. Guys, I've seen a couple of these videos, and honestly, I never want to involve myself in a cruise, because if a hurricane comes, I have no idea what I'm going to do with myself. If the ship goes up like this, I have no idea what I'm going to do with myself. So no thank you, guys. Alright? No cruise ships for me, but let's check it out.
Hey there! Welcome back to the Noctis on YouTube. Why don't ships sink in rough seas?
Because of the shape of them.
This is a question that may have crossed your mind when you've seen large ships sailing.
Guys, I've never understood how these very specific shipping containers even stay on these ships during like these crazy weather events.
In the midst of waves and strong winds. How is it possible for ships made of steel, weighing hundreds of thousands of tons, to float on water while smaller stones or pieces of iron would simply sink? Is there a secret behind the design and construction of ships that keeps them stable and from capsizing?
Yes.
The answer to this question lies in Archimedes' principle, or the concept of buoyancy proposed by the ancient Greek scientist Archimedes. Archimedes' principle states that an object submerged in a fluid experiences an upward force called buoyant force. The buoyant force acting on an immersed object is equal to the weight of the fluid displaced by that object. Gravity acts downward on the object, determined by its mass, while the buoyant force acts upward. In simple terms, if the gravitational force on an object is less than the buoyant force, the object will float. When we throw a stone into water, the buoyant force on the stone is less than its gravity. How can we be sure there is buoyant force? If we drop the same stone from a height to the ground, it falls to the ground at a very high speed due to gravitational pull. However, if we place the same stone in a tank filled with water at the same height, it takes longer to reach the bottom of the tank. The resistance experienced by the stone is buoyancy. How does this principle apply to ships? Ships are giant steel vessels weighing hundreds of thousands of tons. But think again. What helps a ship stay afloat is the shape and content of the ship. A ship is not a solid block of steel. Instead, it's a hollow steel shell. A ship has many components, but the most important one is air. This is called buoyancy reserve. The air inside the ship is much lighter than water. That's what makes it float. The average density of the total volume of the ship and everything inside it, including air, must be lower than the density of the same volume of water. When the ship is placed in the water, it displaces and moves an amount of water equal to its weight. The closer the average density of the ship is to the density of the water volume, the more of the ship will be submerged in the water. If the average density of the ship is greater than that of the water, the ship will sink. When a ship sinks, it's because water enters the ship, forcing the air out, making the average density of the ship greater than that of the water. One of the most famous disasters was the sinking of the RMS Titanic. The ship struck an iceberg off the coast of Newfoundland in April 1912. The iceberg tore small holes in its hull, allowing water to enter the front of the ship. The more water entered the ship, the more air was forced out. This caused the ship to sink to the bottom of the Atlantic. Like any other ship that has ever sunk, the Titanic reached the bottom due to a lack of buoyant force. That's why ships sink. However, buoyancy alone is not enough to explain why ships don't sink in rough seas. There are other factors that also play a crucial role in maintaining the stability and balance of a ship, namely the center of gravity and the center of buoyancy. The center of gravity is the point where the total weight of the ship can be considered to act. The center of buoyancy is the point where the total buoyant force of the ship can be considered to act. Ideally, these 2 points should be on the same vertical line, so the ship remains upright and doesn't tilt. However, in rough seas, the ship experiences external forces that make it sway from side to side or front to back. These forces are called moments, and they tend to rotate the ship from its initial position. A moment is the product of the force and the distance from the pivot point. The greater the force or distance, the greater the moment produced. Moments acting on a ship can come from the wind, waves, currents, or uneven cargo. These moments can make the ship tilt or even capsize if they are not balanced. To prevent this from happening, ships must have good stability. Stability is the ship's ability to return to its initial position after being disturbed by external moments. Stability is determined by the difference between the center of gravity and the center of buoyancy. The center of gravity and the center of buoyancy are not always fixed at one point. They can change depending on the shape and distribution of the ship's mass. When the ship tilts due to external moments, the center of buoyancy shifts in the same direction as the ship's tilt. This is because the volume of water displaced by the ship also changes. The center of gravity can also shift if there are changes in cargo or passengers on the ship.
Okay.
When the center of buoyancy shifts, it creates a new buoyant force that tries to balance the external moments.
So guys, really quickly. So it makes all the sense in the world that cargo ships shouldn't be sinking probably as much as they probably do, right? Or maybe they don't. I have no idea, right? Again, I stay away from these things. But cruise ships have people walking around all day long. Like, how do those very specific ships stay afloat? If you're talking about things that need to be strategically placed in certain places in order for like the ships to maintain overall buoyancy or the center of buoyancy, then how do cruise ships do this? Unless they're like random weights all over the place or something. I guess a human body is not enough to sink one of these mammoth cruise ships.
This new buoyant force works at the new center of buoyancy, while gravity continues to act at the center of gravity. This restoring moment must be greater than the external moments for the ship to remain stable. If the restoring moment is smaller or equal to the external moments, the ship will remain tilted or even capsize. This condition is called an unstable state.
Okay.
To avoid an unstable state, ships must be designed with attention to several factors such as 1. Hull shape. The hull shape determines how much water the ship displaces and how far the center of buoyancy shifts when the ship tilts. A good hull shape has a large surface area and a small volume. This will make the center of buoyancy shift further when the ship tilts, increasing the restoring moment.
Guys, this is literally a brand new fear of mine that has just been unlocked, I'm telling you. I never want to experience that.
2. Mass distribution. Mass distribution determines the position of the center of gravity and how easily it shifts with changes in cargo or passengers. Good mass distribution means a low and balanced center of gravity. This reduces external moments and increases the restoring moment. 3. Ballast. Ballast is additional weight placed in the ship's lower compartments to increase weight and lower the center of gravity.
Yeah, I was wondering, guys. I was like, wait, bro, hold on. How are you, like, doing counterweights? So I'm guessing there are probably also ballast in cruise ships, most likely.
Ballast can be water, sand, rocks, or metal.
It's probably going to be water, guys.
Ballast is useful for improving ship stability, especially when cargo or passengers are reduced.
Because you can take water on at any time.
Stabilizers. Stabilizers are additional devices installed on the ship's hull to reduce tilting due to waves or wind. Stabilizers can be fins that move up and down with the ship's tilt or tanks filled with fluid that can be pumped to the opposite side of the ship's tilt. Stabilizers can reduce the ship's tilt by up to 90%. 5. Speed. Speed also affects ship stability. When a ship moves at high speed, it generates hydrodynamic forces that can balance external moments. These hydrodynamic forces come from the changing water pressure around the ship's hull due to wave shape changes. These forces can either make the ship more stable or less stable, depending on the direction and magnitude of the force. Taking these factors into account, ship engineers and architects can design and build ships that are less likely to sink in rough seas. However, no ship is perfect, and there is no guarantee that a ship will never sink. There are many unpredictable and uncontrollable factors.
Yeah, guys, but dude, has a cruise ship sunk? And I'm not referring to like the Titanic, guys, right? But has like a modern cruise ship sunk?
Factors such as weather, currents, ice, or collisions. That's why designing and building a ship is a time-consuming and complex process. Potential errors and inaccuracies are assessed from the early stages, with preventive steps and testing taken at each step. This is why model ship testing is important from the basic design stage of a ship before it is built.
Okay.
The importance of model ship testing can be explained by its name itself, where large objects like ships can be assessed in miniature scale, allowing visualization of the behavior of the ship and other physical characteristics before the actual ship construction begins. Creating these ship models requires hydrostatic calculations before production stages, and precise model completion is crucial because small errors can have a significant impact on ship design. High-level computing technology has simplified this process, enabling the creation of ship models in a manner similar to the construction of the actual ship. Ship models are usually made to mimic specific types of ships, such as bulk carriers, tankers, and barges. However, simple models are also made for basic studies like resistance and propulsion calculations. All small-scale model experiments are conducted in tanks or fresh...
Guys, I'm going to point out that these guys that are doing this thing, they actually love doing this. I'm telling you, I would love to be one of these guys who did this right here. Like, being able to play with these, like, vehicles all day long, I'm telling you.
Freshwater ponds of various shapes and sizes. A towing tank is an experimental facility primarily used to calculate and solve ship hydrodynamic problems. This tank resembles a long pool, often with a depth of up to 100 meters, and its width is usually determined by the width of the ship model itself. This narrow freshwater channel facilitates various experiments in which the model must move a certain distance without significant cross-movement. When the model is tested, the ship model is placed in the towing tank. There, the ship model is usually mounted on a carriage, a kind of movable platform that moves along rails on the side of the tank, moving in tandem with the model. This carriage not only supports the model, but also serves as a base for important recording equipment, computers, and other data collection systems. Researchers and observers can also ride on the carriage to witness experiments directly. Model ship testing can also be conducted in facilities known as wave tanks. This test simulation is more realistic because these facilities create a testing environment for the model that is similar to the actual sea conditions experienced by the ship. Physically, the wave tank resembles a towing tank. Here as well, the length exceeds the width, far surpassing the depth. Additionally, the depth is not as great, though it can be more than a simple towing tank. Another interesting feature of the wave tank is the trench in the middle of its length. The depth of this trench is quite high and is created for technical reasons. The main idea behind this is to create a sea topography where there are various depths of the seabed, ranging from shallow to depths of around 10,000 feet or more. A unique feature of wave tanks is the wave generator.
Bro, I want to see a ship in here. It looks like you just created a tsunami. I mean, based off of the scale of it, at least, that absolutely would be a tsunami, right? But I don't think the ship's going to make that one.
Depths of the seabed,
this one here?
Ranging from shallow to depths of around 10,000 feet or more. A unique feature of wave tanks is the wave generator. This system produces waves with varying wavelengths, frequencies, and of course, heights. Now the question is, how do we generate waves? The answer can be simple. With wind, by creating pressure variations and disturbances underwater, or mechanically. The mechanical method triggers hydraulic forces, which in turn create waves inside the tank. This wave maker is essentially driven by an electric motor. The ship model is towed at a certain speed, while measuring various parameters such as resistance, speed, and ship behavior. Sophisticated sensors are installed on the model to collect data during testing. This data is then analyzed and used to make decisions about ship design. One critical aspect of model ship testing is ensuring that the data obtained from the model can be applied to the full-scale ship. Therefore, it is essential to ensure that the model scale and the actual ship are the same. This requires a deep understanding of the theory of similarity, which is a fundamental principle in fluid mechanics. Engineers use the results from model ship testing to make adjustments to ship designs, address shortcomings, and optimize ship performance. As a result, ships built based on tested designs will have better performance, efficiency, and safety. This is the explanation of why ships don't sink in rough seas. The engineering marvel that allows giant ships to sail the oceans is the result of a combination of basic physics knowledge, innovative design, and thorough testing.
Guys, I do like the fact that all of these gigantic ships are being tested. It does, well, how about this? I would like to still know, like, definitively exactly how cruise ships are doing it. I fully now understand completely how cargo ships are doing it, but if we could just get the information on the cruise ship, that'd be amazing. Because that one right there, bro, I'm gonna go ahead and guess it's definitely some type of water ballast, like they were stating here. That's probably going to be the way that they're going to probably do it, because everyone is always walking around on cruise, guys. They're not sitting in the same place like a lot of these shipping containers are, guys. And the next thing here is, I think that he was very good with attempting to teach the concept of fluid mechanics, with Archimedes' principles being kind of the main guidelines that anyone that's into fluid mechanics, they are going to be following, guys, right? So in terms of the buoyancy force, that's always the key factor, along with volume and density, and then obviously how things are being implemented within the principle of Archimedes, guys. But he was good, guys. No complaints. Listen, let me know in the comments of the next one of these from him, or any other video that you guys want me to check out, guys, and I will. Enjoy the rest of your day.